Hello, and welcome to The Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. Hi, I'm Adela, and today I'm discussing Cephalopod-inspired camouflage. In this episode, I will discuss a project in the making by the University of Houston and the University of Illinois Urbana-Champaign. This project, inspired by cephalopods, is quite interesting, so let's get into it. Camouflage, as described by Wikipedia, is the use of any combination of materials, coloration, or illumination for concealment, either by making animals or objects hard to see, or by disguising them as something else. Current forms of camouflage that we see today include creating different patterns, typically using greens and browns, to try to mimic the environment. Such patterns and designs are most used for military. The modern military camouflage that we see today was invented in 1915. However, camouflage has been around for centuries, and its main discussion has been around nature. There are several animals that hide within their area through features and colors. Examples include insects like the leaf bug, walking stick, and moths. Arctic animals do this by having white coats to match the snow. Even an animal like the great gray owl has camouflaging abilities, but there is one class of animals that are more known for camouflaging. Cephalopods, for those unfamiliar, are interesting creatures that can blend themselves into their environment. The most thought of animal is the octopus, but others include squid and cuttlefish. Sticking with octopi, the way they are able to change their color is through special cells. These cells are filled with different colors, typically yellow, red, or brown. Muscles that the cells are attached to change the cell's size, which in turn affects the skin appearance. Their unique ability is what inspired researchers to create this device. The device, as described by you, the assistant mechanical engineering professor at Houston, is set to see color and match it. This is done through thermochromatic material. The device is made from layer material, and the top layer has dye that is temperature sensitive. It's black until it reaches temperatures above 116 degrees Fahrenheit. Underneath are reflective tiles, silicon circuits, and a foundation. Following this initial layering, the other layer of the device consists of light sensors. Despite all that was listed, the device measures less than 200 microns thick. For comparison, a strand of human hair is 100 microns wide. The time it takes for the color change to happen takes approximately 1 to 2 seconds. Currently, the device is operating in the grayscale, seeing as it switches between black and transparent, but it is being worked on to adapt to different colors so it can work in all environments. To quote a lead researcher from the Illinois campus, John Roger, the device is by no means a deployable camouflage system, but it's a pretty good starting point. A technology I remember seeing while doing research on this topic was a material that made whatever was behind it appear invisible. This material is called quantum stealth and is in the process of being patented by Hyperstealth Biotechnology Corp. It works by bending light waves around the target. In addition, it also removes infrared, thermal signatures, and the target's shadow. While both the device and the material essentially camouflage a target, they do it in their own way. I think once the device is operational on a larger scale, it'll be neat to compare the two and see which one will be used for what application. There are of course numerous ones, with the military being an obvious area. However, discussions of using the device in areas of fashion or even toys are possible. Imagine having a wristwatch or some other form of wearable technology able to blend in, so only the wearer knows that it is there. It'll be interesting to watch this project evolve and become usable, and how exactly it'll function. Today we covered how camouflage came about, nature's camouflaging abilities, and how cephalopods inspired a new device that is capable of matching its surroundings. We also compared the device to another technology that has been developed. The abilities of nature and the ideas we come up with to mimic them are fascinating, and it's exciting to think about what we will come up with next. I hope you enjoyed this podcast. Thanks for listening.